When I graduated, uh, I did a little bit of shopping around for employment, but I think I kind of wanted to stay around home. And so I took a job with a company that was then called United Technology Corporation. It was a division of United Aircraft. Now, today I think United Aircraft took over the name and calls itself United Technologies. Same company, I think. Anyway, what they were doing, they had a big contract from the Air Force to develop the Titan 3C rocket system. The Titan 3C was kind of a general purpose launch vehicle, and I think the Air Force used it to launch like communications satellites and surveillance satellites. There were a number of different missions. I was not involved at all with the actual operation of the thing. At that point, UTC was developing a part of that system. And that part was the solid rocket motor strap-on boosters that got did the initial launch of the vehicle. So the Titan 3C was a liquid rocket core that was built by McDonnell Douglas. And then these two, they called them strap-on boosters, built by UTC, developed and built by UTC. So I started with UTC in, right at the end of 1962. The program was started, but not, the propellant was all started, the propellant was developed, but the system itself was under development. You know, I just had a very small part of it. I was in the instrumentation section. But looking back, it was a heck of an interesting program. It was pretty innovative. Solid rockets had been around for a while, but these were big. They were, the rocket was about 70 feet tall. Each booster, and there were two of them, was about 70 feet tall and 10 feet in diameter. So that's a big motor to make all in one shot, and they did not make it all in one shot. It was segmented. So the version that I worked on, there were 5 segments, 10 feet in diameter and about 10 feet tall. 5 of them that were bolted together. That's 50 feet. And then with the nozzle and the forward closure, it was about 70 feet. So that was kind of innovative, the segmented idea. And then it had a very creative steering system. So a typical rocket motor, like the Saturn V, has what they call a gimbaled nozzle. So the nozzle swivels to steer the rocket. On the Titan 3C, the nozzles were fixed. And the way they steered the rocket, there was a manifold around about a third of the way down the nozzle, with a series of 24 valves around the manifold that injected a fluid, it was nitrogen tetroxide, a fluid into the hot gas coming out of the nozzle, and it deflected the plume, and that steered the motor. Well, that thing was brand new, and so there was a lot of development work, you know, how to get the fluid to flow, how to make the little valves all work right, how many valves you sequence to get what kind of a side thrust. A lot of work on the rocket guy's part, but a lot of work on our part, the instrumentation guys, to figure out how to measure that in a meaningful way that then they could use to navigate and to figure out. So it was an interesting program. I never actually saw that rocket fly. Because what we did, the test site was at a place called Coyote, which is like 15 miles south of San Jose, up in the hills. Had to be isolated because, you know, things can blow up and stuff. And we fired the motors full scale, but we fired them upside down in a static test. So you put load cells on the front of the rocket, which is now pointing down, and you measure the thrust. And then we had load cells around the sides to measure the side forces, and strain gauges all over the case, because it's a big pressure vessel, a big pressure vessel. I think the chamber pressure ran around 750 psi. So you don't want the case to rupture, but it's got to fly, so you don't want it to be super heavy either. And so there were hundreds of channels of strain gauges to try to get a feeling for how big the case is growing under pressure, enough, not too much. And then that was a challenge because these segments were all bolted together. There was a clevis, and when the case grew, that distorted the joining parts between the segments. That could be a problem. And as a matter of fact, if you remember the Challenger disaster, that was caused by a burn through at one of those clevis joints. The problem was, if you're into your aerospace history, it got very cold a couple of days before that launch. And as a matter of fact, there were people in the industry or in the operations saying it's too cold, we shouldn't fire. Because the clevis was sealed by a couple of O-rings, and then they used to try to fill the voids with zinc chromate putty around this big 10-foot, it's a 10-foot O-ring, if you can imagine, and fill all the gaps. And a number of people were afraid that it had gotten too cold. The dimensions had changed enough that the clevis seal wouldn't be adequate, which was exactly what happened. They had a burn through, and once you get a burn through in a case like that, it's like a cutting torch. And it cuts through the steel case, and boom, it goes. And yeah, it was a very creative program. And my part of it was a little tiny part, But I was looking around, and I was learning a lot of stuff. I did participate in one destruct test down at Edwards Air Force Base. With a liquid rocket, if you want to turn it off, if you want to abort, all you have to do is close the valves that are putting the liquid into the combustion chamber. But with a solid rocket, you can't turn it off once it's turned off. So the abort mechanism was to split open the case. And so down the side of the case, there's what's called a linear shaped charge. That's just a very high explosive, but it's clad in a kind of a cutting shape. So when you light it off, it'll cut through the case, split open the case, and the fire goes out, basically. So that's another subsystem that had to be tested. So we went down to Wiley Labs down in Norco, California, which is kind of out in the boonies. And we laid out these steel plates on the ground that were the thickness of the case. And we laid the linear, I was the instrumentation guy, so I was going like, okay, we're ready to push the button now. But put out the witness plates, they're called, and then put out the LSC, and then cranked up. And this was the days before, high-speed video. So we had high-speed cameras, 1,000 frames a second. And then lit this thing off, and it was sort of funny because we obviously had to recover the parts to see that the witness plates had been properly cut. Took us forever to find the things because we're out in the middle of the boonies. The LSC goes off. It's a huge explosion, and there's like shrapnel going all over the place, and we're going, okay, well, did it work? Well, where is it? We can't even find it. So that was fun. I did go down and witness and help instrument a full-scale destruct test down at Edwards Air Force Base. So they laid the rocket on its side in a cradle that would hold it down. And now this thing generated, each one of them generated about 1 million pounds of thrust. So holding it down, this is why we fired it upside down, you know. Holding it down was a chore. But for some reason, this destruct test couldn't be done vertically. It had to be done on its side. I don't know why. But anyway, they put it in this cradle, locked it down, lit it off. It's going full blast. It's about 35 seconds or something like that into the total program, which, by the way, was only like 90 seconds for the whole rocket to go off. But at 30 seconds in, then you fire the LSC and you see if it really did split the case properly and if the fire did go out and all that sort of thing. And that was fun. That was fun. We went out again after the site had cooled off. We went out and tried to recover the stuff. And I remember bringing back a pressure transducer because we measured chamber pressure in a number of spots. And I think maybe even some of the exhaust pressures. But I remember bringing back a pressure transducer. It's about, this big around, encased in a rock. I kid you not, the thing was like it was in a rock because the fire had gotten so hot that the sand, Edwards Air Force Base, and this pressure transducer fell into the molten sand, and then it solidified. One of the guys had it on his desk for a long time. We didn't know what to do with it. Couldn't recalibrate that sucker. So I was just a very small cog in the machinery there, but looking back on it, it was really an interesting experience. So I was with UTC like 4.5 years. But then